Think we're live. Hi, everybody. This is Gloria from DoraHacks. I'm joined by Dan and Vlad from Evmos. I know some of you guys are familiar with Dan from hosting the previous workshop. For those who missed the very first workshop, Getting Started with Evmos, you can find that on our YouTube channel. But I'm very thrilled to host the second workshop of the Evmos Hackathon today. As a brief overview, this hackathon is an opportunity for you guys to showcase your skill sets and create innovative solutions to improve the Evmos ecosystem. And we're very keen on all the amazing new projects that you guys are working on. So today, Dan and Vlad will be shedding more light on the EVM extensions and how to leverage them for some novel use cases. So yeah, don't want to take up too much of your guys' time. I'm sure you guys have a lot of ground to cover, but it's great to have you. And for everyone else, if you have any questions during the session, feel free to ask in the YouTube and Binance live chat room. But thanks for joining again for those who are returning. So I'll hand the podium over to you guys, Dan and Vlad. So feel free to take it away when you guys are ready.
Awesome. Thanks for the intro. So hello, everybody. I'm Dan. I'm leading product at Evmos. Vlad, do you want to introduce yourself?
Yeah. Hi, everybody. I'm Vlad, and I'm one of the core engineers working on EVM Extensions.
Nice. Thanks, man. Yeah, and I want to give you guys a quick overview first on what we're building at the moment, and basically give you a bit of like context why EVM extensions are relevant, what kind of problems we want to solve, and then we're going to jump into a tutorial or like more examples on how you can use specifically staking and distribution extensions that are currently live on our testnet and soon also will be deployed to mainnet. So let me just share my screen for now to give you like a, just let me know if this works. Yeah, so just as I mentioned, we're just going to go through a quick presentation, which I recently gave in at Consensus, actually in Austin, a few weeks back, and then run you through like a bit more of a hands-on example. And Vlad is also going to take over the last part here with the no loss lottery. It's going to be really interesting. So can you just confirm that you see like the full screen of the presentation?
Yeah.
Okay, awesome, cool. So title is like, how do EVM extensions enable novel use cases in Evmos and simplify onboarding for end users? In the past, we've called these EVM extensions pre-compiles, which is, I guess, a more technical term of this functionality. But actually, we're also like to look at it from like a user perspective and developer experience perspective to really like understand why this is important. So skipping this, just as a quick reminder, what Evmos is and how like this ties into the EVM extensions. Basically, Evmos is a layer 1 blockchain on the Cosmos ecosystem that combines the best out of two worlds, the EVM on the left-hand side here and the Cosmos ecosystem. So the Cosmos ecosystem, allows you to have really like sovereign blockchains with own governance token, governance process, and most of them are on a proof of stake consensus, and it really helps towards like the scalability of layer 1 blockchains. And the EVM is really useful for composability and programmability. So having like really a more agnostic way of writing applications that can interact with each other. And basically, EVM extensions are the key feature in the middle that actually combine these two worlds, and we're going to see a bit more afterwards. So the first two major problems I want to just outline in the current Cosmos ecosystem that are affected by this are going to follow now. So the first one is onboarding users is really hard. There's so many Cosmos chains. or also non-Cosmos chains. They all have their own token. There's maybe different on-ramps, a whole new ecosystem on each chain. And for users that are maybe not crypto native or coming from other ecosystems, it's sometimes also really hard to even find a start. Or if you are on one chain and you're familiar there, then you would always need to onboard separately to a new chain by swapping tokens, changing the network, and it's a bit hard to scale. And so, yeah, we kind of see a world where users don't need to onboard to many chains, but just one, and kind of see that as their home base to be able to interact with more applications and services. And so you see here just as an example that we want to tell users, hey, like go to Evmos, get started, get on-ramped with some Evmos tokens, and then be able to access everything that's in the Cosmos ecosystem. So that's one problem. Second one is that we see applications to be cross-chain, not multi-chain. And what this basically means is we want to ease the process of dApps or decentralized applications to gain access to more users and more communities, but limit the amount of like deployments they have to do and maintaining instantiations of their contracts by choosing a more cross-chain strategy. So instead of deploying the same application on several ecosystems, we think it's more scalable if you have one application on one network, such as Evmos, but then make it accessible to other networks and users on other networks. So those are kind of like the two main things that are relevant to the EVM extensions. So what we're enabling is basically, or like by having EVM extensions, we basically enable the next generation of scalable dApps powered by interoperability. And I'll explain what this actually means. So what you see here is basically an overview of how this functionality works. We call it basically EVM programmability on top of Cosmos. So right now, without the extensions, EVM smart contracts basically are isolated within the virtual machine, within the Ethereum virtual machine. They can talk to other smart contracts on Evmos, but they can't really access information or data outside of it by default. And so if you have smart contracts deployed on the EVM on Evmos, what you can do now with these EVM extensions is you can talk to these EVM extensions, which are basically smart contracts themselves, and access further core functionality on the Evmos protocol. There's like a bunch of core functionality such as voting, staking, but also access to IBC, which is allowing you to communicate to other blockchains over the blockchain communication protocol. And this is actually a big game changer because before this wasn't really possible, like I mentioned, smart contracts were isolated, and now you can actually write programs on top of all the core functionalities of Cosmos chains, such as the standard ones as voting and staking. There's obviously more that we can add, and we're actually in the process of adding. But also you can have smart contracts talk to other smart contracts that are not on the Evmos chain, but on other Cosmos chains or any other IBC enabled chains. And this can also be turned around where like users or applications or smart contracts on other chains can actually enter Evmos and talk to smart contracts on Evmos. So that's kind of the idea of scalable, interoperable applications. And this actually allows for a bunch of new use cases. Right now, as a user, you can, simply stake your tokens and by choosing a validator. But if you actually can write programs in form of smart contracts, then you could, do a bunch of optimizations. For example, have staking managers that stake to a certain subset of validators, or like indexers that, automatically redelegate based on certain criteria. For example, the actual location of the validators and so on. But you could also be, like gas price optimizations, or I guess like have token price thresholds at which you could withdraw your pending staking rewards at a specific like token price or whatever to be more tax efficient. Those are just like some examples. There's a bunch more, and we're going to give some walkthrough on the examples later. Maybe I'll just actually run through this example here. That kind of simulates or shows you how that would work from a user perspective with EVM extensions. So sorry. Basically, the idea is that we have the Evmos chain and like Evmos node that you can interact with. And as a user, you're connected to the Evmos network. And we support several wallets, also Kepler, MetaMask, and Ledger. And a staking index could basically allow you as a user to interact with like a staking balancer. This is just any smart contract, so written in Solidity. And this smart contract basically says, hey, the user, for example, wants to stake 100 Evmos to a subset of validators. And this would be a EVM transaction because it's a Solidity smart contract. And then this staking balancer would talk to the staking EVM extension and actually perform the individual staking calls. So this would just be one transaction. I guess in this case, it's two because you also have a previous approval. I'll explain that later a bit more, but the idea is that you're giving the rights to a smart contract to kind of manage your staking intention. And that can also be, redelegated, like I said earlier. So this is one of the cases where EVM extensions already allow for way more programmability. Another example I want to show is using IBC enabled EVM extensions. So if you're not familiar with Stride, here mentioned, it's just as an example. They're a liquid staking zone. So it's a layer 1 blockchain that allows users to send, for example, Evmos to this chain, and then just like make a liquid staking transaction and receive liquid staked Evmos back, and then they could send it back to Evmos or do whatever with it, send it to Osmosis or provide it as a liquidity pool asset whatsoever. And the thing is, though, that like right now, from Evmos perspective, or a user on Evmos, or any other chain that wants to use Stride, it takes a few steps instead of just one step. That's one thing. We want to reduce the amount of interactions you have to do to actually perform or get back the staked Evmos. And the second thing, it's actually not accessible by smart contracts. As I said earlier, smart contracts in the EVM are isolated and they can't really access data outside of the Evmos chain. So what the user could do here is stay connected to the Evmos mainnet and send the EVM transaction to a smart contract. This is just an example smart contract that I call this here Stride smart contract, like a proxy contract for like a nicer interface to basically manage the call to the EVM extension. But you wouldn't necessarily have to have it. You could also do it directly to the EVM extension for IBC. And what this then would do is it allows a smart contract to basically perform an IBC transfer. And the way that Stride basically works is that once they receive the IBC transfer, they do the liquid staking and send back the staked Evmos. So this is basically what we call an outpost on Evmos, because from a user perspective, or I guess smart contract perspective, you're just interacting with the contract on Evmos. That is the interface for anything that you can do on Stride, and everything else happens in the background. And this could be, like I said, used programmatically. So a smart contract can then liquid stake their Evmos, liquid stake their Evmos and do something in the same transaction when they get it back on the Evmos network. A similar example with DEX outpost on Osmosis. Won't get too deep into this, but the idea is that smart contracts can use an IBC EVM extension, interact with it to, for example, swap tokens. So send the Evmos token and get an Atom back and do something with the Atom token on Evmos, or provide liquidity, for example. Those are just two of the many things you can do on Osmosis. This also is a mock-up. I think we've talked about the dApp store before quite a bit. Like I said, this is just a work in progress, not the final result. But the idea is that, like I mentioned before, like users in smart contracts just need to onboard to one chain, in this case, obviously Evmos, and they can still access the rest of the Cosmos ecosystem. So with the idea of this dApp store, we want to have outposts, but also interoperable dApps on Evmos that you can easily discover and use while being connected to the Evmos network. So you don't have to change the networks. Also, second important part is that you're paying with Evmos tokens for the gas fees. So you don't need to really switch around. We're also doing some optimizations to be able to pay with other gas tokens, but the idea is just you don't need to change. You want to retain the one token that you usually use for paying for gas fees. So that's kind of the theoretical part of the demo or of the extensions. And now we would get into the actual demo of how you can write a smart contract that talks to staking and distribution. So in our academy, we have a tutorial on how to do this, and we're just gonna basically follow this tutorial. So it's actually really easy for anybody who wants to join. They can actually just use this link. We're also gonna leave this in the description afterwards. So let me make this big. So that if you haven't seen the tutorial from yesterday, I suggest checking that out, because there I gave an intro on how to actually deploy smart contract on testnet and use the block explorer to track the things, your transactions, and also use Remix to actually perform the deployment and interact with the contract. And so what we're going to do is we're going to deploy a contract called a simple staker, which is just something we wrote in the core team. One of the core engineers did this to just symbolize like how easy it can be to interact with a staking precompile or EVM extension. And before getting into it, maybe to explain like the way that usually you will run and write the logic is that you have some kind of approval process. So if you want to have a smart contract, I guess, manage your funds or stake tokens for you or for another address, then you first have to approve this action and also the amount for which the ownership can be taken over. In this case, we'll approve for a bunch of messages like delegate or withdrawing pending staking rewards. So what we have here is you can use this link to actually open up the whole project of smart contracts. So this is just I just hosted on GitHub with the simple staker smart contract. Let me just make this a bit larger. And it has basically a very simple, very simple interface. Allows you to stake your tokens from the account that actually is calling this this method. You can withdraw your rewards that are pending. On the testnet, also mainnet, we have daily epochs, so the staking rewards are issued once a day. So we probably won't have any rewards here if we deploy the contract only, stake only now. And there's also some queries that we can do with this contract, like getting a delegation, and also querying the rewards of my delegation. You also see what are the expected returns. So what we're going to do is, or as also I guess important to mention, is we're actually importing the staking and distribution interface. Those are just the interfaces for the EVM extensions. You don't really see like the logic that's happening here, because you can imagine that once you call this extension contract, it'll take the inputs like the delegator address or withdrawer address, and then perform this transaction on the Evmos protocol, which is written in Go, not in Solidity. It will perform the state transition and then return some kind of result. And this interface is basically just saying, okay, this is expected to return a bool on the success of the call. And also maybe for a bit of more reference and context for the people who are not aware of what I mean by staking and distribution, or maybe are not so familiar with the Cosmos ecosystem. So basically, most of the Cosmos chains are structured in modules that you can build. These are a bunch of like standard Cosmos SDK modules, but you can also extend them by your own custom modules, which we obviously did on Evmos. And there's the staking and the, let me just zoom in, the staking and the distribution module that are responsible for the, this is the responsible logic for the proof of stake management, I guess, and the communication with the consensus layer. So staking will allow you to actually delegate to validators, whereas distribution is also has like, you want to make a transaction to the distribution module to actually withdraw your pending staking rewards or querying them. If you're interested in reading more about this is all linked out, and it's quite interesting on how proof of stake actually works here on how it's implemented in the Cosmos chains. So I'm just going to close this for now. Let's continue with. I'll put this here on the side. So we're just going to follow the instructions that we have in this tutorial, starting with compiling the contract, which is the simple staker. So just going to select this one, compile it, and we see it's successful. And then we can select the correct environment. In this case, we want to use MetaMask. So I'm connected to my a developer account. I'm connected to Evmos testnet. I already have some test Evmos on this account. Like I said, if you are not familiar with this, then do check out the video from yesterday, which we also have in the link to the previous workshop is also here. We also have a faucet where you can get started with some Evmos tokens. But yeah, running through this. So I'm just going to deploy this contract. That prompts me to confirm with MetaMask. Okay, great. So we have information on the contract down here, and we have the transaction hash. You can also follow the latest transactions here and view it on the Block Explorer. This is the testnet Block Explorer that's going to show exactly the gas costs and everything, as well as like the internal transactions for the instantiation of a contract. And then once you've deployed the contract, the simple staker, it actually populates all the methods that are part of this contract. And the way that the simple staker works is we have the method called approve required methods. And this is implemented in a way that it approves the staking methods as well as the distribution methods for the sender. So for me, or for the dev account that I'm using here at the moment. Usually you can also define like the amount of which you want to approve for, but the way that it's implemented here is just basically the max value that is possible. So I can also show you that, if we were to, I guess I'll show you this in a second. We can try to stake some tokens without approving, and you'll see that it fails, just to show you that. So let's do that first. If we were to attempt to stake our tokens to any given validator for a certain amount, then we have to actually provide the validator address. In this case, we're already past this part. In this case, you can like query the validator over CLI, or you can also use these publicly facing endpoints. So this is just a list of all the validators on testnet. Selecting the first one doesn't really matter. And let's say, I don't know, I want to do 100,000 TEFMOS. And try to actually send this transaction, it'll fail. So we see it's pending. And it failed, exactly, that's expected. And also you saw that when I click transact, it actually gives me this error, which is about gas estimation, because the way that MetaMask knows like which gas values to use is it basically simulates the transaction. And during that execution, during that simulation, it already notices, okay, there's something wrong with the approval. So just to explain that. So what we actually need to do first is approve the required methods, which are staking and the distribution methods. So this doesn't require any inputs. As I said, we just take the max values, and it's for the sender of the message, and this is now confirmed. And now I will be able to stake my tokens. Let's do this. Confirm the message, and it's pending. Amazing. So we see, trying to make this big enough. So we see that we interacted with the simple staker to stake the tokens. It shows me the gas as well and some logs. I can also look at the logs from the Block Explorer perspective. I think that also is quite interesting. So looking at this last interaction. Also, by the way, if you're experiencing that transaction hash is not found, then this just might because just wait a bit, because this might be due to like the indexing that's a bit slower on the testnet explorer. But usually on mainnet, this is not the case. Just a heads up. So this will also give you a bit more better overview of the interaction, as well as the logs. And this also includes the delegate call to the contract. Also, this is actually quite neat because it tells you that you're interacting with the EVM extension on the staking module, and you're actually able to view the staking EVM extension, its address, as well as all the interactions with this extension, which is quite neat. And yeah, basically have a good overview here. But to continue here, so we've shown how like a transaction works over the interface, and I guess if we look at the code here, we see that we have the staking contract that we're calling here, and the delegate method, and input the sender validator address and the amount as we did it here over the interface. And maybe also to show you, this staking contract comes from the import, which is the, like I mentioned earlier, the staking interface. So we should be able to see delegate exactly, that explains exactly at which address the contract is hosted at, as well as the expected inputs. So it's actually quite simple to write a smart contract that interacts with the staking extension. Okay, so maybe last thing I want to show is just the queries. So I think I've had some tokens staked before here, before showing this in the tutorial. So if I query for my delegation to the validator address, then we'll probably have much more than the 100,000 that we just recently staked. So on the Cosmos SDK, the distribution module takes, basically it's responsible for, or the staking module is responsible for allocating a certain amount of shares to all the delegators, and they're used to calculate how many of the overall pending staking rewards are distributed to the individual delegators. So somebody with more shares will get more staking rewards, and this is obviously based on how many EVMOS tokens you have delegated to validators. So right now, if I let's just stake some more tokens, and then we can query again. We'll see also that the amount of the balance that is delegated will also increase. So just gonna do this again. Oh, sorry. So we just staked some more tokens here. And now if I want to query the delegation here, we're going to see it's going to increase. Okay, hope you saw that, but this one turned from a 6 to a 7, increase the balance here. Yeah, that's basically how you can interact with the EVM extensions on a very simple level. That's kind of all I wanted to show from the simple staker. As mentioned, there is our Academy documentation. I might also want to add our normal developer documentation. They currently look very similar, but this is going to change very soon. So if you go to develop smart contracts, and then you'll have like just the information on also the tooling that we have, like oracles, any like block explorers, contract verification, etc. But it also is going to give you a list of all the currently available EVM extensions, including their addresses for the staking and the distribution module. The ones for IBC are following quite soon, and we'll have a bunch more, such as governance, etc. that will be added as well. There's also a bit more information who's curious about how the authorization works, and yeah, a detailed explanation of the extensions. Nice. So at this point, I'd say that we continue with the no loss lottery, and Vlad, who's hopefully still on the call, can take over.
Yep. Let me share my screen really quick. All right, can you see my screen? Is the zoom level also okay? Can you see it clearly?
Looks all right, yeah.
Okay, cool. All right, so I'll start first by, I guess, pointing you to the extensions repository that we have on GitHub. This repository basically stores any and all examples that we come up with during development. And the idea is that it showcases some of the more important features that EVM extensions basically allow or enable. So Dan showed you the simple staker, which is here. There's also a more complex staking manager. And today I'm going to show you the no loss lottery. And there's a full write-up here, which you guys can read afterwards. And I'll go through some of these points really fast using the code itself. So feel free to check this out and start this as well to keep an eye out and for future uploads. Okay. So the no loss lottery contract, first, let me explain what a no loss lottery is for people that don't know. The idea of a no loss lottery is that people delegate to a validator, and then the rewards they receive each day are then used in a lottery to basically draw a winner based on a random number, but also weighted towards the amount of delegations that people have made. So it's a little fun way of making a game out of your staking rewards. Other apps like this exist on Ethereum, but they don't use staking rewards necessarily. They use, I guess, yields from popular lending protocols. So the idea is the same, but since staking rewards are quite high for Evmos, this is a good way for people to gamify their staking. So the idea here for no loss lottery is that it solves, this implementation in particular solves one issue that we had during development and during just conceptualizing the use cases for extensions, is the idea that the contract itself would be able to stake on the user's behalf by keeping the deposits in the contract itself. So what do I mean by this? If, for example, you use the simple staker, which Dan provided, or Dan showcased, people could essentially delegate, but then undelegate from another Cosmos transaction somewhere else without it being in this specific smart contract. So you can imagine I can delegate, and then I go from my other wallet, let's say Kepler, which is the Cosmos most popular wallet, and undelegate from there, essentially bypassing any custom logic that the smart contract might have. And we don't want that, right? So the idea is that in this implementation, the smart contract itself holds the funds. So I'm going to give you a small demo here, and then I'll go through each of these functions and briefly just describe what they're doing. So in this particular demo, I'm going to use a local node, and I'll explain why in a second once we reach that function. So here I've loaded the no loss lottery contract, and now I'm going to deposit from one of my accounts here, which has 20 Evmos. I'm going to deposit 20 Evmos here, and let me convert it into weight. One important thing to note here is that all of these amounts that we're depositing here are always going to be denominated in IEVMOS, or WAVE for Ethereum devs. So first thing I'm doing is depositing into this payable function. The transaction here has succeeded. So now if you take this address here and go to our deposits, you will see that my address has 20 Evmos, right? So now the second thing I would want to do is enter the lottery. So now this specific function will take a validator address. Let me find it here for you. We'll take a validator address, which is the bec32 format, not the hex format, and then an amount also denominated in way. For simplicity's sake, the number should be whole because it makes the calculations easier afterwards for picking a winner. So let me just get the validator address here real quick, and then deposit that 20 evmos. Here, sometimes you have to just double check the gas estimation because sometimes MetaMask doesn't estimate it correctly here. Confirming this transaction. Okay, so now I've entered the lottery. So now to double check here, we have another data structure here that keeps track of all the delegations that are made. And again, for simplicity's sake, we're only using one validator, but feel free to hack on a project like this using multiple validators. So now if we check the delegations here, okay, since I'm using a local node, sometimes this takes a couple of queries. Okay, now we can see that our delegations are indeed 20,000 and our deposits have gone to 0, meaning that we've transitioned from deposit to delegations. Now let's do the same thing, but with a second account. So we have at least 2 people that would be able to determine the winner of this lottery. So now I'm loading my second account. This account has 101 evmos. Making sure I get the correct account here. I'll just deposit 50, convert it into a evmos. Okay, we've deposited. Now let me get the developer address again. Okay, we've entered successfully. Now we just pick the winner. And again, this function pick winner, ideally you would not want to trigger it or let anybody trigger it. So in your smart contracts, you would include something like an Open Zeppelin ownable contract and make this function only owner. So only you would be able to trigger this function. Usually also picking a winner wouldn't work unless there are delegation rewards. As you can see here, we're using the distribution contract and we're withdrawing delegation rewards. But since I'm using a local node, I have modified the Cosmos SDK to make sure that rewards are actually distributed around about every 60 seconds as opposed to around every 24 hours. So here I'm going to pick the winner. Double check the gas here again. I've successfully picked the winner. So this is another contract. Let me see here. You have a winner's data structure as well. So you can see each winner's rounds. Now this is a contract I've deposited beforehand. So you can see we have 2 rounds. Round 2 is the one that we currently are at. The winning number was 305. It gives you the winning address, the winning amount, and then a timestamp. And you can get the winner address also from another data structure and see how much winnings exactly they have. So now if you want to withdraw the winnings, there is a withdraw winnings function here that will be able to withdraw your rewards. But I think it's the actual other person that won. One of my other accounts here. Let's load this again. This is the address ending in 321. Okay, let's see. 321. It's this one. Okay. So now I'm connected to this winning address, and you can check it here. If you withdraw winnings over here, this time it's estimated correctly. And now I've withdrawn winnings. But just to keep in mind, since this is a local node, the winnings are not very predictable because there's only one validator and a couple of people here. So it withdrew a huge amount of evmos. But it doesn't matter. The point was just to go over the flow, and now I'm gonna go over a bit of the details and some of the limitations here from this doc, just to make sure, first and foremost, this is not a copy-pastable contract that you can just deploy on testnet or mainnet and make sure that it works. It has some limitations. The idea here is to showcase how to build a contract that holds funds within the contract itself and manages state in terms of which user holds what types of deposits or what type of tokens internally in the Solidity contract state. So that's why here we deposit. For simplicity, again, we make sure that it's a whole number, and we add it into a deposits array for the message sender. And we, of course, emit a deposit event. The second function here that's important is the enter lottery, which also has the same restriction here. The thing that Dan mentioned, approving the required messages, very important. Otherwise, delegating wouldn't work. So you always have to make sure that you use the staking contract and the distribution contract approved messages. Another big thing while I'm here is that here I use transaction origin for the approve to make sure that the end user or the EOA is the actual person that's approving the contract. Now, I've decided to implement this in this way to ensure that the EOA is always the one that has approved it, to bypass some possible exploits. But when you're pushing this to testnet or to mainnet, ideally you would want to use message sender here, and this would allow other contracts to basically call into your contract. So if you build an all-loss lottery or you build any other DeFi dApp or anything like that, you would want to use message sender, and that way the contract that's calling your contract would need the approval. So that's something to keep in mind. And for this use case, I just use transaction origin because it will be just me sending it through my MetaMask. Okay, so here, oh, this is exit lottery, sorry. So here, once the delegation is complete and it hasn't failed and everything has been going through, I make sure to use address.this for the delegator address to make sure that it goes through the smart contract and not through the end user. And here to make sure that I keep track of which user has deposited or entered the lottery with the amount of tokens, I keep it in the delegations array, and then a deposit, and then I take away from their deposits. I also keep track of the total staked and the total tickets, and I'll explain the total tickets is actually the way that we decide who is the winner of the lottery. Here, there's also a bunch of logic to make sure that I'm not entering a participant twice. So if it already exists, I push it once. Or sorry, if it doesn't exist, I push it once. But if it does exist, I just pass here. Okay, so the pick winner, which is the bread and butter, I guess, of this implementation. First, it tries to withdraw delegator rewards using the contract address and only one validator address. This is another thing that you guys could solve. For this implementation, we only use one validator address, and we define it ourselves. We pick it ourselves. But in a production main testnet, mainnet contract, you guys could offer smart contract users the ability to delegate with whichever validator they want, and then keep track of these validators, and then I guess loop through all validators and withdraw and keep all of the delegation rewards in the contract from each and every validator. So the first thing we do here afterwards is we shuffle the participants, because the participants will be entered in order of which they deposited and entered the lottery. So first we want to shuffle that to bring a little bit of randomness into who's being picked as the winner. Then we do a random number generator. So for this random number generator, I've just used the block number and timestamp and modulo by the total tickets to make sure that the random number is within the total tickets. So for example, if I deposited 50 and somebody else deposited 50, it's 100 total tickets, and we need that number to be within that 100. This is another limitation. In testnet and mainnet, you would want to have an actual oracle verifiable randomness here, because a validator here could basically know or calculate the random number if he knows how much total tickets, and it would not be random at all. So this is another limitation you guys keep in mind. And there's a couple of oracles that you guys could use that are on our docs. We can share with you guys afterwards. So now we just loop over the participants, and we sum all the delegations they have, and then we check if these delegations that they have are within the winner index, or equal or larger than the winner index. And if they are, then that is the winner. So the idea being is that the more tokens you have deposited and entered into the lottery, the bigger your chances of winning. And this shuffle participants also make sure that there's a little bit more randomness. So sometimes people that have a slightly lower chance could also have a shot at the pot and a shot at winning everything. And here we also add, just for convenience sake and for display sake that I showed you guys, a winners array and a winnings amount as well. One thing to keep in mind with exiting the lottery, I'm not sure if everybody's familiar, but I'll just explain it anyway. But whenever you stake your tokens with Evmos or any other Cosmos chain for that matter, if you want to undelegate them afterwards, there's an unbonding period. So in the case of Evmos, it's 14 days. So whenever you undelegate your tokens here, they're not automatically coming back to you. You need to wait 14 days for them to actually come back to the contract address. And once they come back to the contract address, then you can go and you can withdraw them. So that's something to keep in mind. One way you can improve this, actually, just didn't have time to do it, but just came to me, is that you can actually listen in for events on the Cosmos side. So you can use Tendermint events, which is the underlying consensus engine, and then listen in for events, because every time an undelegation is complete, there is an event emitted with the address of the user and the address of the validator. So one thing you guys could do is listen in for that event, for that undelegation event. And once that undelegation event happens and it matches the user's address and the validator address, then you can trigger another function on the on the Ethereum side on your smart contract to automatically send those tokens back to the end user. So he would basically bypass having to come back after 14 days and then withdrawing them himself. So this basically does that. This creates an unbonding request, takes the total stake off, increases the deposits for manual withdrawing afterwards, and takes away from the tickets. Here there's a couple of view functions. I think you guys, they're pretty self-explanatory. Some of them use the actual smart contracts here, the extensions. Some of them are just plain old Solidity functions. And yeah, I think I've covered most of this. If you guys have any other additional questions, feel free to drop on Discord on the Evmos builders. Actually, I think we can take questions now if there's anybody watching this and in YouTube. But if you manage to actually catch this on recording, feel free to drop on Discord or on Telegram. I'm Alora on Discord, so or basically just Vlad.@Evmos, and I'm also Vlad@Evmos in Telegram. Feel free to ask me questions. I'm always happy to help, even review some of your Solidity code and get you guys deployed on testnet.
Awesome. Thanks, Dan and Vlad. Yeah, just double checking. Does anyone have any questions? More than happy to take some. Okay, well, quiet crowd today. I'm sure they'll ping you on Discord. I know that we do have a couple minutes to spare. I just wanted to ask you guys if you guys hadn't answered this already, but in terms of like the hackathon and the projects itself, are there any like particular projects that you were hoping to see like built out, or what are like the types of projects that you personally are super like interested or keen on seeing?
Yeah, for me
Vlad, do you want to take
specifically,
this one?
yeah, sure. So for me specifically, I've had a lot of time working on extensions and trying to figure out some of the use cases in building these. So I have a lot of apps that I would want to see and I would use daily if some of you guys make these. But one very particular one I want is a sort of DCA manager, an investment manager, if you will. So using my staking rewards, being able to convert on a popular DEX like, say, Forge. So I could set an automated amount of tokens I want to have each month. Let's say my portfolio is 60% Evmos, 20% osmosis, and then a couple of other percent for something else. So if I just set that and balance it and then stake some EVMOS, every time using my rewards, the goal of the smart contract is to balance my portfolio to the percentages I want. So we can call it a portfolio balancer, but using also the staking rewards, right? Another big one I think that is very important for not just personal reasons, but decentralization as a whole, is a staking rebalancer. So something similar with the portfolio balancer, but the idea here is that if a person wants to stake with multiple validators, right? But it's very tedious to withdraw from each validator and take all your rewards in. How about building a smart contract that does all of that for you automatically? You just set the amount that you want to stake, and then the smart contract takes care of redistributing that stake equally, maybe amongst the top 50 or maybe amongst the bottom 50 validators, or even you can pick the ones you want. And then every time it's just one click to take away or to get all the rewards back from each and every validator. So stuff like that, I think, would be really super important, and I would use it honestly every day.
Also, to add to that, I think it's important to understand that redelegations don't take a bonding period or unbonding period, so those can be instant. So you can redelegate to another validator without having to wait 14 days. So that's why it would be actually super useful.
Yeah, awesome. I think that's some very helpful information for some developers to know and definitely keep in mind. But I know that it's time to wrap up. So thanks again, Dan and Vlad, for providing some really great insight behind, the problem that the EVMOS extension is solving, regarding the onboarding hurdles and just like easing the dApp process to just improve scalability. And also, I'm sure everyone appreciated the general step-by-step tutorial. And like the EVMOS team mentioned, they do have those links available for like the EVMOS Academy and their docs, and obviously their Discord for you guys to access. And while this workshop is over, just a friendly reminder, I think we have more workshops in the pipeline for you guys. And be sure to follow us on YouTube and Binance Live for more like valuable workshops and project demo sessions. And I know that everyone is busy building, the next best project to be seen in EVMOS. And yeah, I hope you guys had some great takeaways that you guys are able to incorporate in whatever you're building. So thanks everyone for joining.
Thank you. Take care.
Thanks for having us.
Guys, bye.
Bye-bye.